So this is the front side of the worksheet. Now, if you're watching along at home, again, I said I'm not too concerned about the back of the worksheet. Just the front of the worksheet is really where I'm going to answer questions from. So my first thing here is I'm going to use data from attendance to social media posts, right? Attendance to social media posts to see if our attendance gets influenced by the social media post, basically. Or maybe I can say something about that social media post. So attendance. So this is game A. This is attendance 635 out of 125 posts. Okay. So 635 out of 125, 5.08. And that is a person coming per social media post. Okay. B is 590 over 108. Okay. So 590 divided by 108. And that is 5.46. Yeah, 5.46. Okay, now we can say that game B, maybe the social media posts were more targeted. More people came per social media post. More people came to the game per social media post for game B than game A. I don't know what was different about the social media post, but maybe there was something different enough to where more people came for game B than came for game A. Is that good, Nathan?
Yeah.
Yeah. You asked that question. Pay attention. What's going on?
Yeah.
What other questions do we have? Yeah.
Number 5. I don't know how, but I got 2.0.
You got what?
0.0.
Ooh, that'd be an issue.
Yeah.
Let's take a look at number 5 here. Now, this is another one of those ones where I set up similar triangles, trying to find the height of the totem pole, see if it's going to fall in the visitor center. So we can say 5 foot 9 inches over 5, object over shadow is equal to object over shadow. X over 40. Am I using the 43 at all in my calculation just yet?
Nope.
No, that does not have anything to do with my calculation. What do I have to do with that 9 inches?
Divided by 12.
Good, divided by 12. And when I do that, that's going to give me 0.75. So it's not 5 foot 9 inches, it's 5.75 feet. And now we cross multiply. We say 5.75 times 40. And then we divide by 5. So we get 46. Okay, 230. So 230 is equal to 5x. And then we divide by 5. We get 46 feet. So what can I say? What's my conclusion now? No?
It will hit the visitor center.
It will hit the visitor center if it falls. Yes. All right, any other questions on the worksheet? Okay, let's go through the warm-up real quick. This 4.75 miles to meters. Now, remember that when I take miles to meters, you start by writing out what you have. And now, I change miles to meters by chaining it together with something that's going to get me to meters. Because, guys, is there a miles to meters conversion on our sheet? No. But there is miles to kilometers, isn't there? There is miles to kilometers. I have 1 mile is 1.609 kilometers. Now, remember, where does the miles go in my conversion? Top or bottom? Bottom. It's got to cancel out. 1 mile is 1.609 kilometers. But I don't want to end with kilometers. I want to go all the way to meters. So I say 1 kilometer, think back to science class, 1,000 meters. 1 kilometer is 1,000 meters. Are all my variables going to successfully cancel out? Well, I got miles and miles, kilometers and kilometers. So I've just got my meters left over, and that means, oh, look, I got ones along the bottom. This is the easiest conversion. 4.75 times 1.609 times 1,000. And that gets me 7,642. 0.75 meters. Here's my answer. Questions about that? Logically think it through. Okay, I've only almost got 5 miles. Is that gonna be a lot of meters? Yeah, it's gonna be a whole lot of meters. There's a math term, a whole lot of. Means a lot. All right. Now, in my opinion, there could not be 2 more drastically different days than yesterday as it compares to today. Because in my mind, but the section 2-1 might be the easiest section that we've done all year.
What? No.
Okay, now let's talk about chapter 2. We are done with chapter 1. You're going to see the homework binders. You're going to see the homework binders cleaned out tomorrow because chapter 1 is now completed. Now we're going to be getting to chapter 2. Now, what is chapter 2 then? Well, chapter 2 is all about inequalities. Inequalities. Not equalities, but inequalities. When 2 things are different from one another. Okay? Not the same, but different from one another. All of chapter 1 was x plus 2 is equal to 10. Where I can say, yes, definitively, I want x plus 2 to come out to be the exact same as 10. Equal to 10. That was all chapter 1. And how do we work with that? Chapter 2 is all about when things are bigger, smaller, bigger than or equal to, smaller than or equal to. And that is called an inequality. An inequality. So our formal definition, which you see on your papers there. An inequality is a mathematical statement or a sentence that compares expressions. It compares them. It doesn't set them equal. It compares them. It says, okay, one is bigger than, one is smaller than. Okay? Not necessarily the same as. It could be the same as. That's where we get the or equal to. But one is bigger than, one is smaller than. That's what we're working with in chapter 2. And that's all chapter 2. Now, I've got to be straightforward with you. A lot of chapter 2 is a review of chapter 1. Because how do we solve inequalities? The exact same way we solve equations, with only a couple little tricks to make sure we remember. Okay? So what is an inequality? An inequality contains a symbol less than, greater than, less than or equal to, or greater than or equal to. To write an inequality, look for the following phrases. Now, I'm giving you a grouping of phrases that is extremely important. One of the most difficult things to do when writing an inequality is determining what sign to use, especially when you're working with a word problem. If you're working with a word problem, it's really difficult to tell, what am I going to use? Less than, greater than, less than or equal to, greater than or equal to. Because if you use the wrong symbol, your answer is going to get way off. So, obviously, across the top of this, that's exactly as it is. This is less than, this is greater than, this is less than or equal to, this is greater than or equal to. One thing that, I say this to students, it kind of blows their mind. When you do this symbol, remember that's just, if you turn your head to the side, that's just an L. So that's just less than, right? I say that to people and they're like, what? You gotta be joking. Yeah, that's just, if you turn your head to the side, it's just an L. So that's your less than, right? So that's how to remember which one's less than, which one's greater than. And then if you have the line underneath, it's the or equal to. Now, these down here, those are the context clues that you're going to see in word problems. That's more often what we're going to have. There are going to be times when I'm just nice to you and I say, okay, it's just greater than, or just less than, or just greater than, or less than. But there's a lot of times where I say, okay, 15 is no more than 2x plus 7. And you have to decide, okay, what inequality do you use there? Well, if it's no more than, we see that on our list, that's less than or equal to. Because if it's no more than, that means it can't go over it, can't go above it, it's got to stay underneath it, less than or equal to. Is at least. X plus 7 is at least 32. Okay, well that means it's got to be more than 32, right? At least it. It's going to be greater than or equal to. 32, because if it's at least, it could be equal to that. Okay, these are the context clues that we're going to see a lot that really trip some people up. Think about it logically. Usually that'll tell you what symbol to use. Now, for these next three examples here, I just want you to write the inequality. I don't want you to do any solving. We've got to crawl before we can walk. Let's take a minute and just write the inequality. A number w minus 3.5 is less than or equal to negative 2. Okay, well, let's just write it out. A number w minus 3.5, okay, is less than or equal to? Less than or equal to negative 2. That's all I want us to do right now. Just write out the inequality. Because again, I tell you, most of the time, the difficulty is going to be not just solving an inequality, but how do we create the inequality, especially based on word problems. Do the next two on your own. Try the next two on your own. They should be pretty simple. Do those next two on your own. Write out those two. You probably did. A lot of like the first section, we usually go 2-1. Yeah, and again, we're going to crawl a little bit through these first couple sections. Because section 2.2 is just solving by adding and subtracting. Section 2.3 is just solving by multiplying and dividing. Section 2.4 is multi-step inequalities, where we added 2, 3 steps. Okay, so we're going to go a little bit slowly through these next couple of sections. Okay, but by the end of the week, we're going to be solving inequalities, just like we solve equations. So 3 is less than a number n plus 5. 3 is less than a number n plus 5. Pretty simple, right? Just transferring words to mathematical symbols. 0 is greater than or equal to, okay, here we go, twice a number x, 2x, plus 1. How do we do on those two? Easy peasy, right? Maybe the only thing that tripped you up was the twice a number, 2x, but we've done that before. Okay, so now we can now we can write an inequality. Now, how do we tell if something is a solution? How do we tell if a number is a solution? How do we tell if a number is a solution? Well, to tell whether something was a solution before, all I had to do was plug it back in, right? Thinking back to equations, all I had to do was just plug that thing in. Now, it's similar in inequalities, but when I go to plug it in, I just have to determine if that statement was true. Okay? Before it was like, oh, does the left side match the right side? Then it worked. Now, it's a little bit more difficult. Okay? Like, for example, and now this box is left intentionally blank for you to fill in on your guided notes. If I have the value of negative 6 for this inequality, x plus 5 is greater than or equal to negative 2, all I do to test to see whether negative 6 is going to be a solution is to plug it in. Negative 6 plus 5 is negative 1. And then you have to decide for yourself, is that a true statement? No longer is it just like, oh, it's equal, so it's the same. So we're good. No, that was equalities. Now we've moved on from that. We're saying, okay, now I have to decide whether that is a true statement. Is negative 1 greater than negative 2? Yes. On a number line, negative 1 is bigger than negative 2. So therefore, it is a true statement. So yes, negative 6 would be a solution. Okay, similarly, if I had negative 7, now be careful here. Just because it's an or equal to doesn't throw that off. Now that just gives you another option. It has to be bigger than or the same as negative 2. So when I plug in negative 7 plus 5 and I get negative 2, because it comes out the same and because there's an or equal to, it's still a solution. Okay? Now, when I jump to negative 8, that's when it's no longer a solution. Negative 3 is no longer greater than or equal to -2. So therefore it would not be a solution. So we notice here that multiple things could be a solution. Like for example, if I wanted any number bigger than 5, like think, if I wanted any number bigger than 5, would 6 work? Yeah. Would 7?
Yeah.
Yeah, would 8? Bigger than 8? Bigger than 5?
Yeah.
Any number bigger than 5. If I had any number bigger than 5, it would be a solution, right? I have a lot of different possibilities. What I'm saying here is that my solution is no longer one number. It's an infinite set of numbers. So we can no longer say just one value. This is an infinite set of values that we'll be able to graph, okay? So let's go up to the back page, the top of the back page, and let's test to see if these are solutions. Let's test to see if these are solutions. Okay, I've got x plus 8 is less than 4. Let's test to see whether -4 is a solution to this inequality. Well, all I need to do then is just plug in -4. We take -4 plus 8. Is that less than 4? Is -4 plus 8 less than 4? Well, -4 plus 8 is +4. Is that a true statement? No. What would have made it a true statement? If it was an or equal to there. Good. So, but we can't say this is a true statement. So we say, no, not a solution. That's an exclamation point. That's like a, no, not a solution there. Okay. Let's take a look at the other one. Let's plug this in. -4.5. And I've got -3 getting plugged in. Let's see if this is a true statement. Well, -4.5. Come on. -4.5 times -3 gets us a positive 13.5. Is that a true statement? Yes, it is a true statement. Positive number bigger than a negative number. Yep. So this is a true statement. So therefore we know, yes, -3 is a solution to this inequality. Is it the only solution? No. There's a lot of different solutions.
Oh,
Questions about that? And you know, if you ever get confused about that, because I know we kind of second guess ourselves sometimes. I learned way back when that the alligator should be eating the bigger number. Chomp, 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 chomp. Yeah, the alligator always chomps the bigger number. All right. So we learned what an inequality is. We learned how to write one. We learned how to tell if something is a solution. And now what we're going to look at is how we graph it. Okay? Now, thinking back to graphing, I'm sure you guys have done this before. You guys remember the whole deal with the open circle or the closed circle? Remember, the closed circle means that's the or equal to. Okay? If there is an or equal to on that inequality, you put a closed circle on the number line. If there is an open circle, that means that's a less than or a greater than. Okay? An open circle is used when a number is not the solution. Like, so if it's x is greater than 4, where 4 is not the solution, well then I have to have an open circle at 4. But if I change it to x is greater than or equal to 4, that's when I would close that circle up. Okay? That means that the solution is part of that number. So let's graph y is less than or equal to -3. So here's what we have to decide. We have to put the dot where it should go. We have to decide whether it's open or closed. Then we have to decide whether it goes left or right. Okay. So it's at -3. Is that going to be an open or closed circle at -3? Closed circle, because it's the or equal to. Now, which direction does that arrow point? Does it point to the left or to the right?
Right.
Ooh.
I'm not left. I'm not left.
He meant left. He meant left. He meant left. Now, when you graph it on your papers, please don't just like draw over the line. Because there's going to be a lot of times on your test where I can't see that. I can't see that you're just drawing over the line. Please do what I'm doing on the board. please make it go up and over. Now, what does that mean? That means any number where that arrow goes could be a solution. Could -4 be a solution? Yes. -5? Yes. Could 0 be a solution?
No.
No, the arrow's not over there. Now, do you guys know the trick about the symbol points the way the arrow goes? Look at this, everybody. Eyes up here, everybody. This is going to blow your mind here. Do you see this symbol here? That's the arrow.
That's crazy. Exactly, dude.
I know.
That's actually mind-blowing.
And that always works as long as the variable is on the left side. And I'm going to be picky about that. I want the variable always on the left side. So if the variable is on the left side, you can use that rule about, okay, if it's a less than symbol, this is the way the arrow is going to point. So it's going to go down here. Let's see if that works over here. Now, do you know offhand where 5/2 goes?
No.
I mean, if you don't, then turn it into a decimal to estimate where it should go. What is 5/2 as a decimal? 2.5, 2.5. So put a little mark there where 2.5 should go. And yes, I will take off points if you don't put it in the right spot. Okay? So if it's 2.5 and you put it in between 1 and 2, I'm going to take off a point. Happens all the time. Then put your dot and label it. That's always good to label. That's 5/2. Put your dot, open or closed? Open. Is this going to point to the left or to the right? To the left. Look, here's my arrow. Here's my arrow. There it is. Any number to the left of 5/2 would be a solution. Is 5/2 a solution? No, but anything below it would be. One more of those. Z is greater than 0. Open or close circle on 0. Yeah. Excuse me. Open on 0. Going to the right or to the left? To the right. Look, here's my arrow. Anything to the right of 0 would be a solution. Now, whenever you're doing your homework and there's not a graph provided for you, like on every quiz and test, I will have a graph provided for you, like I did on your guided notes. But on your homework tonight, I purposefully leave off a number line. So say like I'm doing problem B. Actually, let's go problem back A. What if I did not have a graph there? This is the bare minimum that I need. I need you to write a number line, and I need you to put a number to the left. I need you to put a number to the right, and I need a number where your point's going to go. That's the bare minimum. If you're going to draw out your own number line, I need 3 points. Something to the left, something to the right, and then put the line where your number's going to go. Okay? That's the bare minimum that I would need. Okay, now let's flip it around. Let's take the graph and write the inequality. So here's our 3 things to decide what to do here. I've got to put our variable on the left side. I have to decide, first off, is it going to be a less than or greater than symbol? Less than, right? Because it's pointing. Look, you can just do this. Here's my arrow, right? Okay. So x is less than. Then I have to decide, am I going to add in an or equal to? No. Because it's the open circle. We have to decide, okay, is it open or closed? Since it's open, I leave off the or equal to, and then I just put it where the number is. X is less than 2. Okay, do your other 2 there on the paper. Do C and D, or sorry, B and C. Again, put the variable on the left, decide which way the arrow points, then say, okay, do I have to add in the or equal to? Okay, for part B here. Greater than or less than? Greater than. Points to the right.
Greater than or equal to.
Ooh. Greater than or equal to.
I said something.
Negative 0.5.
I said.
Oh, I got it. All right.
I'm smart.
I think we should like it
Now, why is it an or equal to? Because it's a closed dot. Right? It's a closed dot. Question.
What's the difference between having the variable on the left compared to the right?
If you flip the variable on the other side, the symbol must change with it as well. See, like this is okay, let's do this problem. X is less than 2.5. That's the way I would write it. This is also an equivalent statement. 2.5 is greater than X. If you flip the position, you must also flip the symbol as well. Yeah. That's why I like the variables on the left, because it's going to match the whole symbol being the exact same thing as the arrow pointing.
For A, I have it on the left side. It's on the left.
I would always put the variable on the left.
But I didn't do it.
But you did it the right way. Then that's fine. Yeah. All right. I'm going to give you guys I'm going to turn off the video, and then I'm going to give you guys your homework. This goes